Welcome back, everyone. This is the day 3 of Open Fabrics Alliance virtual workshop. Just looking ahead before we start the agenda again. So tomorrow we have some presentations from our partner organizations, Gen Z, CXL, and also a bird of feather discussion led by HPE. In the morning, we do have a conversation about open fabric management architecture. So I'm looking forward to the discussions tomorrow. And on Friday, there is also a few sessions, couple 3, and then the TPC members are trying to gather, talk about their journey putting together the workshop. So just a reminder about those. That in the chat window, I have put in the survey links. And as always, you can ask a question anytime during the presentation to keep it as interactive as possible. You can raise your hand or ask a question through the Q&A panel. I will find a way to open your mic so you can ask the question yourself to the presenter. Next, coming up, we have Ariel Almog from Mellanox Nvidia now. Ariel is a senior staff software architect at Mellanox, at Nvidia now, formerly Mellanox, where he helped define software architecture for networking features, including Ethernet, RDMA, and InfiniBand over various OSs. In the past, he has worked on access networks and IP phones, handling ancient SS7 switches and some extinct technologies such as ADM. So I'm very interested to hear what Ariel has to say to our OFA community. Ariel, I'm going to try open your mic now. Just a second. There you go.
Yes, thanks, Divya. So, hi, good evening, good morning, whatever. Happy to be here after all this time trying to make this conference happen. In today's presentation, I'll go over some debuggability feature that we have been working on for the last couple of years, and it is mainly trying to share some information on new feature that we are adding to allow better debug capability for RDMA. You'll find here, I hope, many helpful links that will help you if you have any debug that you need to do with RDMA devices. And in addition, I will be very happy to grab some information from the audience. So if there are ideas of additional debug functionality that is needed, I encourage you to step forward and ask for it. We are ongoing and we are trying to have more and more capability as the RDMA system are being well deployed and some customers are asking for more debug and more visibility on the system. So if you can move to the next slide, please. So the agenda for today is, first of all, to have a vision of how do we see the debuggability feature, then to go through some debug flow. It's some list of tests that we gather which help debug RDMA. It's in early stages, but we are starting to work on it. Later, I'll talk about the difference between Ethernet and RDMA. And in the end, I'll speak about the RDMA tool, the tool that we are developing in the community. So everybody is welcome to contribute there. It's a part of IP Route 2 and it's help to access various RDMA information. And last, I'll talk about some new feature that we are adding called What Just Happened. So if you can go to the next slide, please. Okay, so let's start by our vision. So as I said earlier, there are more RDMA cluster and they are more dense and they are bigger. And there are various applications that are using it. So it's not just a user which uses a single application on top of it, but some users are using different application on top of that. And sometimes the application and the network provider is not the same person, and it's hard to debug in such a cases because you don't know which application broke your network or vice versa. So our target or our vision is to have a runtime monitor, which is something that will allow the administrator to monitor its network and to see whether something is broken and to get some real-time alerting on issues that occur in the network. So it's basically get some information, maybe self-healing. So if we see that some cases can be handled by themselves, we are not there yet, but we are thinking of adding later on some technologies that are based on an AI to have better self-healing of the network, like moving of traffic between nodes in case of congestion and stuff like that. And if a problem needs support, then to grab all the debug information for further analysis. So we try to solve the problem by ourselves. If we can't, we notify the administrator. And if there is a need for further debug, we would like to be able to fetch as much information so the administrator or maybe the vendor itself will be able to analyze the case and to understand what went wrong and how to avoid it in the future. We are talking about traces, counter, and about allowing customer to perform high-level debug, because we all understand that we as a provider, we as a vendor cannot debug each and every setup, both because the equipment is at the customer premises and we don't always have access. And in addition, if the customer can debug by himself, he get the knowledge of how to debug, he is smarter, he can handle it in its own time zone, it is faster cycle, and customers do appreciate that. So we are trying to provide as much information as possible to the customer so the customer will be able to debug by himself, and only if we see that the problem cannot be resolved by the customer, we step in and help in debugging it. We are trying always to work in upstream. So we are trying to push all our tools, and you will see in the end of the presentation, the RDMA tool and what just happened. We're trying to push as much as possible into Linux kernel. And we think that that's a good approach. It's allow a community view of that. It allow adding of additional tools on top of what we have submitted to the kernel. So we are progressing in that direction. However, sometimes there are some features which are very vendor specific and cannot be exposed through Linux community. And for that, we sometimes try to push it to the kernel through new interface. Sometimes we succeed, sometimes we fail. So our guidance is that if we see no way to push it to upstream kernel, we are building a tool which should be open source tool, and it going to be provided in some open Git so everybody can see the source of the tool and user can use it. We are trying to push it to some distros as well, and by that allowing the customer better availability of the tool. And I added here then the last bullet, which is security is an issue. We always have to keep in mind that when debugging, we are exposed to customer information. And we always have to evaluate whether the things that we are exposing for debug might break some law or might provide too much information, and we always have to keep track of that. So that's important point, and it's becoming more and more important as we are progressing, because we all know that network neutrality and confidentiality of information is becoming more important than it was, and it is always important to keep it in mind. So if you can skip to the next slide, please. Yeah, so as I told earlier, I will provide many links inside this presentation. Feel free afterwards to jump in and to see whether it helps you. You can always bring feedback on the link so we can improve it. As you can see, it's all Mellanox link. It's quite hard for us to move from Mellanox to Nvidia. It will take us a couple of weeks, months, years to get used to the new name. So you'll see here, sometimes it's Mellanox, sometimes it's Nvidia. I apologize for that. It's now Nvidia, but the links are still valid. It's in Mellanox. And I guess that even when they'll move, we'll keep some soft link to the original site. So in this community page that we published, we try to do some flow that will allow customer to debug Rocky by himself. And the first flow that you see here on the right is the basic debug flow, which is Rocky doesn't work. What did I do wrong and how can I fix it? So for each such step inside the scheme, there is in the community page a step-by-step guide on how to run the tools, and it's all upstream tools. So the RDMA tool, the IP link, show guide, or whatever, and a success fail criteria. And for each such a test, we have additional step, which can be go to the next step, or it was resolved. Kudos, you can move on. Or if we couldn't make it work, grab this information and call our support. We will help you with this information. Tell us that you reached that step, and we will take it from there with the additional information that customer provided. As you can see on the left side, there is a performance improvement. So now we are working on adding an additional scheme of how to improve performance, how to measure performance, and how to tell whether it's a okay performance or not, and how to check and improve it if it can be done. So the left side is much more complicated. It will take us some time, but the right side already proved itself as valuable, because customer now can go through this flow, correct stuff if it's something basic, and they don't need to start looking around which tool to use and what went wrong. They just go through the flow and they are okay. For that flow, we use some information that we got from application engineer and field application engineer. So we grabbed the problem that customer has experienced in the past, and we try to address them through this flow. Okay, if you can move to the next slide, please. In the next two slides, I'm going through some comparison between Ethernet and RDMA. So a lot of our customers are coming from the Ethernet market, and they would like to have tools, replaceable tools that they can say, okay, I used to do that in Ethernet. How do I do it in IB? And the next two slides provide some RDMA tool that do the same or similar functionality. So for each tool, if you are using RDMA over Ethernet, each tool is working, and it can be configured as you were used to configure it, and you can fetch the information. It works the same. So nothing new here. For IP link, so some information is using the same interfaces like the MTU, mark setting, shaping, etc., etc. However, some information for Rocky can be exposed either through SysFS or through a RDMA tool in the future. And currently, all the IB tools that are that exist already. For TCP dump, the replacement is the IB dump. For IPF3, we've got the IP send lat and IB send bandwidth. For NetStart and open sockets, we developed the RDMA tool, which I'll provide some slides later on RDMA tool, so you'll get a better view of this tool. It's a very neat tool. We started to develop it like 2 years ago, and it became quite large. So we'll talk about it in 2 slides or so. Can you move to the next slide, please? The LLDP tool and DCB tool, it's used mainly for PAUs and PFC and application priority. So it's the same tool for Ethernet and Rocky. And if you are using TC, which is replacing the IP table, various type of rules which do manipulation of traffic. So some of it is supported through TCS-EASE, and some of it needs some Rocky extension. It is not one-to-one. We still have gaps there, and we are working on it. And if you want to visit this community page, the link below will bring you there. So that's for the Ethernet versus RDMA.
Hey, Ariel, there is a question from the audience. Suri?
Go ahead.
Suri, the question is about IB dump, if that works on CNX cards.
If that works on?
The CNX card, CNX5 cards is a question.
Yeah, it should work on any of our Nvidia. I did it okay on our Nvidia network cards.
Okay. Anything else, Suri, you'd like to add?
Can I speak?
Yes, we can hear you.
Okay. It used to work on ConnectX 3 and 4 cards, and it broke with the ConnectX 5 cards. So I'm not sure.
So if it's not working on ConnectX 5, it's a bug, and it should be fixed. There is no architectural limitation. In Mellanox, we are keeping backward compatibility. So starting from ConnectX 3, 4, 5, 6, and now we're working on 7, and the Bluefield device, the SmartNIC, all of them are using same interface and are supporting the same functionality. So if you have something working on ConnectX 4, it will work on Bluefield and on ConnectX 6. And if it doesn't, it's a bug.
Thank you.
No problem. So if you can move to the next slide, please. Okay, so now I'll talk about the RDMA tool. The RDMA tool is a tool that we started about 2 years ago. I think that Jason talked about it last year or the year before that. And Leon is doing all the submission there and is managing the tool. It's an upstream solution. It's part of IP route 2. So if you download IP route 2, which contains, I guess, 80–90% of networking tools inside Linux, you'll get it. It has the IP link and TC and devlink, which I'll talk about it in the last slide. So it's the IP route 2. This is the man page. And if you jump to the next slide, we'll see some sample of this code. Okay, so the first one is the dev. And the dev provide information on the device itself. So you can see the GUID and you can see the firmware version and you can see various capabilities that are supported by the device. So basically the dev provide all the information on the device. Next slide, please. The next one is the link state. And I guess that you got the feeling that it's replaced some of the sysfs functionality that you used to have, and it's correct. It's like putting it in an official tool. So here you get all the link, whether the link is active or not, up, down, etc., etc. And if you can move to the next slide, which is more interesting, I guess. Yes, it's the resources. So here you can start seeing the thing that this tool can provide. For example, you can get the list of open socket and the status of them. You can get it in JSON format if you would like to have further analysis in some tool of the information that it's provided. So basically, if you need some debug, you can get all the QP information from within this tool, the RDMA tool, the resource part. And the next slide, if you can jump to it, is providing all the counters. So all the counters that you used to have in sysfs, they are still there. However, in the resource dump, in the RDMA tool, we added the ability to fetch all this counter. And then we have decided, due to some customer asking for that, that we can have even more granularity of counters. So currently, if you open a Mellanox device, you'll see a single Q counter, which provide all this information, but all the QPs that are open on this virtual function or physical function that is running. And if you can move to the next slide, please. We have developed a mode called auto. And in auto mode, you can define that you would like to have some criteria and to have Q counter bound to QP according to these criteria. So for example, if you would like to have all RDMA QP to have a single counter and all DPDK QP to have a different counter, or if you like to have for each PID a dedicated Q counter, or in the future we are planning to add here per dest IP. And that's allow you to have a more better fine granularity counter per something, per destination, per process, per type of traffic. And it's allow you to debug your system in a better way. You'll be able to see that you get the error only on the traffic or retries only on traffic that is going to some destination IP, or you see that you get some timeout, but only on this process. So it is either the automatic mode where you can bind the, where you ask the device to do automatic binding based on some criteria. And in addition, you can bind yourself in a manual way, QP or QPs to a Q counter. So you can ask to have, for in this example, that QP322 will be binded to a Q counter, and you can add additional QPs to this counter, and it will be only for a dedicated Q counter. We didn't break backward compatibility, so if you are used to the old counter, the general counter, it still exists. You can get the information on the entire device. However, here you got a better granularity of error, and it's allow you to have better visibility of what went wrong and how to debug it. So that's a neat aspect of RDMA tool, the open socket and the counters here. And I think that that's bring me to the last slide, which is the what just happened. If you can move to that, thanks. Oh, we are missing some square. Is there some animation? Yep. Excellent, amazing, another, that's it. Okay, so what just happened? What just happened is another tool that we have developed. It's part of DevLink. DevLink is another package which is part of IP Route 2, and we, in the last 2-3 years, we have been pushing a lot of code there. It is maintained mainly by Jiri Picaro. And what just happened, idea behind it is that customer doesn't want to fetch information and try to grab it all the time. So we would like to have it the other way around, meaning customer will register on some event, and when an event happens, it will get some notification. So it is divided into some blocks. The 3 blocks on the bottom are blocks which are part of Linux. The 2 blocks in the bottom are part of Linux. So we have the hardware and firmware, which is our device. On top of that, we have in the driver and kernel, the devlink. Devlink, there is a command devlink trap. And in devlink trap, customer can ask to have a trap of, for example, all the drop traffic due to a mismatch in VLAN or mismatch in DMAC or no destination QP, etc., etc. And all this traffic will go to user space. It goes through the net device, and then it goes to Linux Dropwatch, and from there it is in user space. User can do whatever he like to do with that. The small box on the right side, the user space tool, bring me back to the first slide when I said that we try to do everything inside the kernel, but if we can, we do some stuff in user space. So currently for what just happened, we didn't add nothing to the user space tool. However, it is there because we have to keep in mind that we need to support it. And the 2 blocks above are basically user domain. We provide some sample, we provide a code that runs there on how to fetch information from the device, how to configure it. So user can either use our sample code and build his application on top of that, or just do the library and application by himself and communicate and fetch all this information to the some monitoring application. All of this is being developed as we speak. It is not out yet. You can see it on Mellanox switch on our HCA. It's not exposed yet. Hopefully it will be there by the end of the year. And that's bring me to the end of my slide. So I'm open to any questions, suggestion.
Thank you, Ariel. Any questions for Ariel? Okay. Thank you, Ariel. If I receive any questions offline, I will definitely reach out to you, okay?
Okay, thanks.